Hello. This is a video response to a question from a student about number 4 from worksheet 10. And what we need to do in this problem is to name these 3 quadratic functions. So we're going to do each of these in this video, and just to help us kind of organize our work, we're going to do this one first, we'll call that A, do this one second, we'll call that B, and we'll do this one third, we'll call that C. So what I've done before starting this is I've written out the 3 different forms we can represent a quadratic in, and that is standard form, vertex form, and factored form. And the key thing about this problem, or whenever working with quadratics, is picking the form that works best for you. And what defines that is what information is given to us. So for example, if we happen to have the vertex form is a very nice form to try and calculate. If we happen to have the roots, or zeros, which are simply the x-intercepts, factored form is very nice to work with. Though standard form is nice for some purposes, typically when we're trying to figure out the equation of the relationship, standard form isn't the best one to work with, though there are ways to do that. So let's start with A, shall we? So if I take a look at A, I ask myself, what do I have about this? Well, I know that I have the vertex, so right away I'm going to think vertex form, and that vertex is at 0, 7. I also know that I have a single point, which we'll call P, which is -3, 16. So my thinking here is that since I'm given the vertex, I'm going to actually write down vertex form below it. So x minus k squared plus h. So now, notice how I actually wrote down the general formula. This is a good passive memorization technique. By writing out that formula every time, you will memorize it. So now I'm going to sub in the vertex, A, and we have x, and we know our k is our horizontal shift, so we go minus 0 squared plus 7. So we end up with a x squared plus 7. And one thing you might notice here is that vertex form, when our vertex happens to be on the y-axis, is actually standard form. One of those interesting, unique cases. But the same principles apply. So now what I want to do is I need to find A. So to find A, I have to plug in a single point. One thing that's important to remember here is that when you substitute in a point to calculate one of these values, you have to be aware that if you're working in vertex form, you cannot sub the vertex in. If you substitute the vertex in, what happens is the A value disappears because you end up multiplying it by 0. So now we do a little algebra. So 16 is equal to 9a plus 7. Watch that, minus 3 squared is positive 9. So I have 16 minus 7 is 9 equals 9a. So therefore a is equal to 1. So thus the name of that relationship is y equals x minus 0 squared plus 7, which more appropriately would be written as x squared plus 7. One little thing to point out here is that, remember, you could pick A directly off of this graph with a little bit of inspection and some tricks we've developed. However, we want to make sure we understand this algebraic process. It's this process that you're learning which, when applied later, will help you solve many more challenging problems. Okay, let's do B now. So B is an interesting one because if I take a look at this, not only am I given the vertex, which is at 8, 0, but I'm also given, this vertex also happens to be the root, which is the x-intercept. So that's pretty cool. That means we can actually approach this problem in a variety of ways. And I also note that I have a point, and that point is going to be 10, 8. So we could use this using vertex form. Excuse me, that's the bell for next period, so we'll just let that ring. There we go. But I'm going to do this using factored form, just to kind of give an example of this. So one of the things I notice here is that this is what's called a repeated root, meaning that meaning that yes, there's a single root here because it only touches once, but when I write it factored form, I have to make sure I account for that. So this is going to be a, and then we have x minus 8. But what happens is we write this in twice. And we'll explore this in more detail with some more examples a little later. But it's a little thing here. So now all I do is I substitute in the point that I have, and that point is going to be 10, 8. So 8 is equal to a, and then we have 10 minus 8 times 10 minus 8. So we have 8 is equal to a times 2 times 2. So 8 is equal to 4a, and a is equal to 2. And I feel really good about this. So y is 2x minus 8. And since it's x minus 8 times x minus 8, I can say x minus 8 squared. I actually feel really good about this. And the reason is because this a value is positive, and I can see that this quadratic relationship opens up. Let's do the last one, shall we? We're going to do that one. We'll do that one in what color? Let's do it in green. So this is going to be c. We'll do it down here. And so what I note here right away is that, in fact, I have the two roots, which is awesome. So I have the x-intercepts, we can say, and the x-intercepts occur at negative 12, 0, and negative 2, 0. I also have a point which is 0, negative 6. Let's scroll this down just a little bit, shall we? That's a little better. So now what I'm going to do is, since I have the x-intercepts, I'm going to set up my factored form. So y equals a, and if it's minus 12, it's going to be x plus 12 times x plus 2, because when I sub in negative 12 into this, I should get 0. And now I'm going to sub my point, so negative 6 is equal to a times 0 plus 12, 0 plus 2, so we get negative 6. And let's do two steps at the same time. 0 plus 12 is 12, times 0 plus 2 is 4, so 12 times 4 is 24. So we're just going to come over to here. So therefore, a is equal to negative 6 over 24, and we're going to reduce that to negative 1/4. And again, I feel good about that because I notice this quadratic opens down. And there are a number of other checks I could do for this. So therefore, the name for that relationship is y equals negative 1/4 x plus 12 times x plus 2. And I'm done. So there it is there. So there's C, there's B, and there's A. So if we come back up here, what I want to stress is that by picking the right form based on the information you're given, you can have a lot more success working through this material. You can find this written solution inside your shared OneNote. Hope that helps.